Hello, everyone. Welcome to the EdTech Society Masterclass 32 Large Scale AI and Learning Engineering Insight from the Field. So, before I introduce our speaker today, just want to talk briefly about the EdTech Society, those who are joining first time to this session. So, EdTech Society, it's a non-profit organization to help uh, the learners, researchers, different people who are working with educational technology and make a public forum so we can bring the researchers and the practitioners in the field. So today, that is what we are doing. We are bringing the researchers and the practitioners who are in the field. They can hear more about what's happening in the research side. And apart from this monthly masterclass, we do have an annual event called Technology for Education. It's an international conference that we organize every year. And this year, it's in IIT Madras in December. So please go and to our website etsociety.org. So you will be able to see more details about the conference and different themes. Lot of details available in the ET Society website. Okay, so without further ado, I am very excited to hear from our speaker today. Let me introduce Mr. Nirmal Patel, and he is the CEO of an edtech entrepreneur and the researcher, and also CEO of the Smart Paper, an edtech startup focused on using AI to connect paper and digital, and also a chief data scientist at Play Power Labs. So leading edtechs aren't the labs, and there are a lot to say about him, and he has published more than 10 research papers on this field. And we are so excited to hear about this new topic that he's today we are going to hear about it. Okay, so without further ado, Nirmal, the stage is yours, and please welcome to EdTech Society's Masterclass event.
Thank you, Briju. Thanks for the introduction, and it's great to be here at EdTech Society and talking about learning engineering. And it's a research topic that I've been working on for almost over a decade, or close to a decade, I would say. And along the way, I learned a lot of things about building digital learning systems that are effective. And so, a short introduction is my name is Nirmal Patel. More recently, I've been building an AI for grading paper assignments, which is called Smart Paper. And I also lead the data science work at Play Power Labs. It's an edtech R&D organization, and we help other organizations develop amazing edtech products. I'm based out of Gandhinagar in Gujarat, and we have our offices here. So next I'm going to jump into a little bit more details about my work. And so I started working in edtech in early 2011. A lot of my early collaborations are with researchers from Carnegie Mellon University, specifically School of Human Computer Interaction, where there is an edtech research group. So I've been associated with them, and then I've been independent researcher at my own company. I've published at various venues like ACM Chi, IEEE, Intelligent Tutoring Systems, Journal of Computer Assisted Learning, and Education Data Mining Journal. And I've also received awards for some novel research that I published, and also at Tech Innovation Awards, more specifically for the Smart Paper Innovation. And I'm very interested in EdTech for its potential for positive large scale social impact in the world of digital learning, because now learning tools and materials are available digitally, which creates a unique opportunity to deliver large scale positive impact through work in edtech. So I'm very excited about that prospect with edtech and the possibility of positive social good. So So that's a little bit about me, and then I'm going to now just jump into the topic of this masterclass, which is learning engineering. So I'm going to start by first talking about what the term means, and here let's talk about who coined the term. So that was Herbert Simon, and he was a cognitive psychologist, and he argued that social sciences, including field of education, and this was argued in 60s, 70s, should be approached with us mathematical principles like physics and engineering. It's a very quantitative approach, and that is a very interesting way of looking at education research, and it is more applicable when you think about digital learning. So you would think that it would only be more interesting to think about learning engineering in modern times. Well, think again. The first education technology that was created was in 1960s. It was a computer called Plato. You can look it up on the internet. And in fact, it was one of the first computers to be ever made. And it was a great computer, and it had many things, and all of those things were designed to be in service of the goal of doing education using computer. And so at initial years of computer systems development, education was one of the core use cases that ignited a lot of development of computer systems itself. And Plato was one of the very widely acclaimed computers. You could talk with other people, you could play games, and if you read some research papers, you also find that people wanted data reports about students learning on Plato computer in the 1960s, right? So you could think about these quantitative approaches within computer learning systems even back then, which is quite interesting. And but there have been challenges, and of course, like you first thing you think is, if you are a researcher, you think about sample size and how many students you can get on these computers if you only had 5 of them. And so fast forward many years later, people are doing education technology. uh, Early as you had these video games. So these pictures are from Mumbai's Dharavi, where my colleague Professor Derek Lomas, with whom I've been doing this learning engineering research for over a decade, is was this is from 2009, when they were trying to develop digital learning applications for the 8-bit games that were quite popular. And so to think about it, digital learning revolution, I mean, one aspect was computer, but this was the aspect where people were trying to make games. And then again here, when my colleague, they were developing this technology, they thought about learning engineering. They thought about being evidence driven in development of these games. And the idea was that we could collect data about how students learn on these games, on these video games, which were then educational games, and then use that data to improve the efficacy, and which is the core and of learning engineering, which I'll come to that in a little bit later. But again, running experiments on such platforms was difficult. And so the core of learning engineering has been around ease of running experiments. And around 2014, so this is around 2009, around 2010, 11, 12, around that time, many online platforms started using online users for their psychological experiments, and then later that was extended to education. But the initial start of these very large scale experiments was started with Facebook, that did several psychological experiments to understand people's emotions. on Facebook, and of course they got very bad press, and the press said that people were used as guinea pigs, which has been an argument in education, when you run experiments digitally. But this was a time when learning engineering also as a field, I believe, became like more relevant, because then you had many users, you had of edtech platforms, and then you could run large scale experiments. And that's what we did back around in 2011, 12, 13. So I'll share more about that. And but just a little bit about what Facebook did. You can look on the left, there is an experiment in Facebook that shows that there are two ways of showing the comments in any post. Either it's collapsed or the comments are shown. And you could run these experiments, and there's this very interesting paper from, I think it's 2014, and which is about designing and deploying online field experiments in Facebook. And Facebook created this system called Planout, which is still out there. It's quite antiquated now, but it was a system to make it easy to run experiments in Facebook. And these were mostly sort of cognitive science, kind of psychology experiments, and people were trying to optimize for different measures. The measures could be total time spent on Facebook or how many likes you have done. So that was the overall approach of optimizing for some measures by doing experiments. And and there was Facebook. And this is when people started doing it in the edtech sector. And so this is a paper, I think, from around the same time, and this is from several folks at CMU HCI. And this paper, it's called The Rise of Super Experiment, uh, is the paper where researchers showed that the large scale experiments that Facebook and others were doing were also possible to do in education in a way that benefited the technology development or the education technology development. And some of the early examples were shown. And one of the early examples was a game called Battleship Numberline, on which we did extensive research, and I was one of the key authors of that educational game, where we ran a lot of experiments. And I'll maybe show how those experiments look like. But by doing those large scale experiments, and I'll talk about the scale, which was thousands of users within a week, you could get causal evidence about various theories and how they work within the digital learning environment. So to kind of put together these ideas, the various ideas that I've talked about, learning engineering is aimed at uh, multiple things. One is that we are trying to improve the learning outcomes of the students, and the other aspect is that we are also trying to improve or advance, which is the right word, the science of learning. And so the way learning engineering cycle works is you have learning theory, which is educational research. Learning theory will inform the development of educational software. Once you have this software, and the software is reaching millions of learners online, this is true today for several platforms, then you can run controlled experiments within those platforms. Now those experiments could be of many kinds, and I'll show some examples. They could be about content, they could be about user experience, and it's just infinite possibilities of running any type of controlled experiments within a digital environment. And the one of the key reasons why people prefer running experiments in digital environment is that it's so cost effective and it's quite rapid. So you are able to advance the science of learning more rapidly when you're using the digital environment, compared to running offline experiments, or even if they are online but you are just there in person with within classrooms or in labs. And when you run these experiments in the digital environments at scale, then you develop more theory. So you contribute back to the science, and also you are improving the educational software. And so this is a sort of virtuous cycle of learning engineering, which can be used, this process can be leveraged to continuously improve the efficacy of digital learning technology. So this is the key idea behind learning engineering. So now I'm going to show how this process would look in a context, in a real context, and I'll show a concrete example of this game, which is called Battleship Numberline. So this game is an educational game, and it's about improving or developing and improving number sense of kids, or maybe people of any age. And there are several mechanics that teach how to use a number line and understand the number line, because number line is a foundation of higher mathematics. And one of the facts that are quite well known is that if you do well in fractions and number line understanding, then you do very well in mathematics later. If you struggle with understanding number line and fractions, then there is a very high chance that you'll struggle with maths later. And so this was the reason why we focused on this game, is to develop this sense of numbers. So the way this game works is students or users will be asked questions where you're identifying a number on a number line. And there's several mechanics. Either you would be identifying where a particular target is. So here, to make it enjoyable, people, there are these robot ships that you can blast using pineapples, and not missiles, it's pineapples, and it won't hurt the ship really, because it's just a fruit. And so it's like harmless fun. And you're just trying to find the number on a number line. If you do it wrong, then there are cues. If you want a worked example, in the latest version of this game we also have a worked example, and it will teach you how to find a number on a number line, even using various strategies. And another mechanic is that you have to type a number where the target is. And so there are multiple mechanics in this game, and then we experimented with several things. The And let me show you the most typical example is experimenting with difficulty. So for example, if you ask where this target is on the number line, if it's on 5, and if the ship is quite big, then even if you throw it at 4 or 6, you'll still get a point. But if the target is very small, you have to be quite precise. And this game was about teaching number sense, and it was more than like being very precise. It was just developing this sense of numbers, that this quantity would be this much. You don't need to know something exactly, but of course, if you have advanced knowledge, then you would know. But when you're developing that number sense, you know we assume that you wouldn't probably know, you still be in the sort of the zone. So this way the game could be more challenging or less challenging, if if I had target size more or less. And with this particular change, what we were trying to find was, one of the metrics that we were trying to optimize was for game engagement. So let me talk a little bit about metrics uh, that we want to optimize. I think it is core to learning engineering, and it is one of the key things that you think about as an experimenter, is what do I want to improve. In this particular game, we believe that the longer people played the game, the more number sense they would develop. And what we tried to optimize for was total seed time, how long people played in seconds. So that was our exact metric. You could try to optimize for pre to post test learning game, and there are various other metrics, but experiments that I will show are more around optimizing the total time played. And so why pick this difficulty, why optimize difficulty to optimize, or why change, or why experiment with difficulty, or why find optimal difficulty? Well, actually, this theory of optimal difficulty came from several studies in chess. And in chess, there are studies, I think by Professor Mihai, and which showed that in online chess games, when people had players who had people had opponents who had roughly equal ability, they enjoyed the game the most, they played the longest, they had this flow state while playing and all of that. And so our hypothesis was that if we could find an ideal difficulty for Battleship Numberline, for this Numberline game, then the game is operating at its best for teaching the number line, because it's the most favorable on average, because it wasn't personalized. We wanted to find one average that worked the best across everyone. And so this was the first experiment. Of course, when we ran the experiment, we found that in our game, the easier it was, the longer it people played. So that was not aligned with the chess study. So this is the sort of interesting part of running experiments, because you may not always confirm what some other study found. And so then we ran several other experiments in this game to sort of deconstruct the idea of difficulty in an educational game. And then we found that there were several factors, not just difficulty. There were several factors that could impact engagement. So this is the research then we published later. This is the sort of later paper. We published several studies before. This was the sort of last big study we published, which also got an honorable mention at Kai. And this in this study we deconstructed the idea of difficulty in an educational game, and we found that uh, there are things, for example, even things like a novelty in a game, where how many new type of questions you are asking can also be perceived as, or can also become difficult for the students. And so when we found that earlier, the difficulty that we thought was the construct, which is difficult on the right, easy on the left, this was not the only type of difficulty. We found several other type of things which we call them challenges. And within those challenges, we saw similar relationship like in the chess study. If you had optimal challenge, then you played for longer. And so this was sort of an interesting uh, deep dive into an educational game context to understand the student psychology. Now, all this research we were able to do because we would get thousands of users every week of this game, Battleship Numberline, which was then hosted on brainpop.com. It was quite popular, still around, I believe. And so that enabled us to run these experiments rapidly, analyze data, and understand, um, you know, the validate our hypotheses. If it was classroom studies, it would have taken way longer. And so this is, I believe, is a beauty of learning engineering in today's time, when you can run experiments rapidly because you have so many people using. There's some platforms where there are so many users, and so I believe we have this unique opportunity to run experiments that can shed light on a lot of things in these platforms. So, now I'm going to talk about how we did learning engineering 10 years ago, maybe 12, 13 years ago, and how we do it now. What's the ideal way to do it now? So I'm going to talk about some tools. So these are some real tools that you can use, and I'm going to talk about two tools. One is called Upgrade, and I'll share the website and how the tool works that in the next slides. And then another tool is called Resource. And so 10, 12 years ago, we ran randomized control trials in our games using XML files as configurations for the RCTs. And so if you had a random variable, then all of their possible values would be defined in an XML file. And you would also have the content for the game. So for example, here you can see there is a way to set difficulty, which we are manipulating here as an experimental parameter. So it has, less difficult to more difficult. So you only have to be 75% correct, for example, to get a point, versus you have to be 97% correct. So all these were different possibilities, and as a user, I would get randomly assigned to one of these conditions. Now you can see some conditions are repeated because we wanted to give them more assignment weight, and so that was our way to change the probability of condition assignment. And similarly, we had other experimental parameters, including time pressure, right? How much time are you giving to the user to answer the question? So these were the experimental parameters, and we had then the content itself. And we had this old style UI in Flash, which I made to quickly create these experimental levels. And then you get a link, and then you can give that link to someone, and or host that link somewhere, and then people would come there, and you get all the data. And you would collect all the data about the condition assignments and what people did, and all of that data then was used to do the analysis. um, and so the idea was that, if we can collect this data fast, we can validate our hypotheses fast. And the randomized control trials meant that we got causal evidence, we got really gold standard evidence. Of course, there are some challenges with these online anonymous type of experiments where you are not able to control for all parameters about your users. But as the sample sizes got quite big, you would see strong trends in the data. Of course, you will also think about p hacking, but when another possibility that was enabled through these large sample sizes was ability to run large factorial um, experiments, where you could be testing for many things. So this was long back how we ran experiments. After several many years, now there's this amazing tool called Upgrade. And that tool has been developed by Carnegie Learning, and we have also contributed in this open source project. And you can use this platform to instrument A/B tests or ABN experiments or various types of experiments within your EdTech platform. And this tool is specifically designed to support educational experiments, and you can get it at upgradeplatform.org. And if you need some help understanding how to use it, feel free to reach out to me. I'm happy to share ideas. But the way this tool works is, once you have this tool hosted, you can create, or you can start experiments within your EdTech app from this tool and manage them easily as a researcher. You can also collect data about those experiments via this tool. So this tool helps you manage the experiments quite easily compared to how we did with files before. That was kind of challenging. And the way this tool will interact with the application is that you design these experiment points or decision points where you get a condition assigned for a user, and then based on the condition that is assigned, a random condition, you show the user a certain experience, A or B, and then mark your user's enrollment in the experiment, and then you log some outcome data, which is also then aggregated with an upgrade. So this makes it very easy. So you can define conditions, you can give their assignment probabilities, and now we have several ways of doing experiments. You can do within subjects, between subjects, or even there are different ways of doing the assignments. And so but the idea is that you make it very easy for researchers. Once your application is instrumented with these decision points, then as a researcher, even while your application is live, you can start and stop experiments and collect data. So then it makes very becomes easier to run experiments in live applications. And decision points are places that you want, or things or features that you want to experiment with. And one could be, for example, time pressure in this game. One could be content difficulty, uh, but it could be anything. It could be background, it could be what sound you are using. Maybe you are using Indian classical music as introduction and things are better. Who knows? Maybe you can test that theory. And so what becomes easy is to rapidly test different theories and collect data. And that makes learning science more fun because you're able to rapidly validate your hypotheses, build new hypotheses, test them, and iterate. And so just with Battleship Numberline, we had some of these things that I shared, like time limit, difficulty, and we had this mission mode. Like, is mission mode is you know inspiring people to do more things? Who knows? Let's run an experiment. Let's do mission mode. So this was sort of, and maybe the answer is no. So oftentimes you find it doesn't matter. And so, but with this experimental apparatus, it becomes just so easy and rapid to test these theories. And so this is just like how this, on the right side you can see there's this mission mode. There's some mission given to the user, and then there are different ways. We either show the guides, not show the guides. So there are different conditions that we tried, and we would find different results. There is another interesting thing about learning engineering is that even when you have many users, many subjects in the experiment, if your experimental conditions are too many, again it's going to take a long time, especially if you're running a factorial experiments, if you're testing many things at once, because you'd be tempted to test so many things at once. In this case, there are machine learning algorithms to more rapidly discover the winning condition according to your measure, whatever your measure may be. If it's total seed time, then if you are running an factorial experiments, a factorial experiment, which has three factors and four conditions in each, then it's going to take a long time if you assign each condition equal number of times. But you could have these machine learning based methods. And in this case, in this paper, actually in Battleship Numberline, we used something called multi-arm bandit, which is a very simple version of reinforcement learning algorithm. And you could, the way it works is that if you if you have many conditions, let's say you have 3000 conditions, um, then the algorithm will, and if you want that, ideally, for each condition you want 100 subjects, what the algorithm will do is it will first assign the experiment all 3000 conditions to 10 users each. Then it will get some preliminary data about the outcome measure, like where your outcome measure, which might be seat time, for example, is the maximum. Of course, you'll get huge error bars at that point, and your measure will not be very confident, but you still can use some heuristics at that point, to not further investigate certain conditions that are really not working well. And so you could just cut time to find your best condition, best optimal condition. And so this is another avenue when you start doing experiments, and the more conditions you want to test at once, you may also end up in this situation. So when you try to run experiments on edtech platforms, you always run into issues about ethics, and getting approvals, and there are several arguments, right? If A/B tests are everywhere, if it's on Amazon, if it's on Flipkart, then why not on an edtech platform? We only want best for the students, but it will take some experimentation. Even in medicine there is experimentation, and teachers also experiment with teaching methods. But of course, people do argue that don't experiment with my child. And so there are practical challenges when you try to do this, specifically when you try to do it in a classroom. If you're doing it in online anonymous setting, then I think it's much more acceptable form of experimentation. So when we ran these experiments, one of the things that we realized was that the harder part of running these experiments was engineering these decision points, different conditions. And that meant that to run these experiments, you had to have a software engineer with you. And that was still difficult. I mean, maybe things have changed with the era of AI coding, but to run experiments, you may need to engineer things, and that also became sort of a roadblock. And so we tried to go around it. How do we solve it? And so we made this new tool. So of course, if you have this if you have team of engineers, if you have and if you have people who can engineer different conditions, and integrate tools like upgrade into your platform, then you're good. Then that's your best way. But let's say you are a researcher who doesn't have that kind of support, uh, but you still want to run experiments. Then how do you do it? So to solve this problem, we created this tool called resource. And the main goal of resource is to make A/B tests very easy, specifically A/B tests around educational content, digital learning content. And so resource makes it very easy to run these experiments, and let me show you how that works. So, and resource is also winner of uh, one, I think a year ago, yeah, we won tools competition grant for doing this work. And resource is also available on resource.education. That's the website, and it's a free tool for researchers. And I'm happy to share how people can use it. But the way it works is that you create conditions, each condition, and the resource is designed right now to best support experiments to compare efficacy of different type of digital learning content. So say you have two videos teaching fractions, which one is better? You can use resource to quickly create an experiment. You get a link, you send the link to 100 people, maybe it's a WhatsApp group. You send the link as an assignment, and then you get concrete data about what worked better. And so running an experiment becomes very easy. Now this was an example about a video. Say you are trying to build a chatbot prompt that will teach a certain concept, and you have made two prompts and you don't know which one is better, so you want to run an experiment. And so that's where resource can help you. You can create two conditions, both of those are prompts, and then you get a link, and when students open that link, they get randomly assigned to one of the conditions, and they'll get a chatbot that starts with a specific prompt that they've been assigned. And then there is a pre-test, post-test, survey. And all this happens with a web application. So as a researcher, you don't need to engineer things. You just work on designing your experiment, creating your content, and then experimentation becomes easier. Um, so here's a UI of resource. You can create an experiment. There's some information, basic information, then you enter. uh, Here, for example, I'm creating conditions about AI tutor prompts, and so I can enter prompt 1, prompt 2, condition 1, condition 2, which will be the AB conditions. Or you could have ABN, so you could keep adding conditions. If you have 3 or 4 or 5 prompts, you can add all of those. uh, and the version that's available right now on the website also supports YouTube links, or you could have any sort of iframe. So even if your colleague has developed some digital intervention, you can just get their link. That would be one condition. The other condition could be a video. The third condition could be a chatbot. So it's quite flexible in comparing different digital learning resources. And so you can create an experiment like that. After that, we have set a very nice way to collect pre-test and post-test data. So you can ask open-ended or multiple choice questions as a pre-test. You can add whatever questions you want. Similarly, you can add post-test, and all of this will be presented to the user. And at the end, you can also ask for some qualitative feedback if you want from the user, that on a rating scale, how they like the experience or what they learned from it. You can ask them questions, and this is often very helpful to understand the qualitative insights. And so once you create an experiment, you get this interface. You get a link to the experiment which you can send to anyone. It's very easy. You can send it in Google Classroom or Moodle or WhatsApp group, or via email. And whoever opens that link will be randomly assigned to one of the conditions of the experiment, and then you will get data by each condition, and you get all of the data from for that experiment, which you can download on your computer as a CSV file, and then you can do your analysis. And so when someone opens the link, for example, this was an experiment about teaching experimental design. And so when you open that link, you start with some introduction. Whatever you have entered as an experiment designer is presented to the user. There's a pre-test. Then, for example, this is a AI chat condition. So the whichever prompt the user has been assigned will be used to steer this conversation. And then you can end the conversation, or you can end this in certain time. For example, if it's 10 minutes, and this will end in 10 minutes, and then the user will go to post test. A similar can happen for either YouTube video or iframe conditions. So at the end, there's post test. On the right side, you can see there's feedback form. It's there. And so just I'm just gonna share a very small experiment we ran. And we got and this was about the experimental design tutor. And here's one, and then you can read the chat. You know and the idea was to not only understand which prompt was more interesting, but what kind of AI tutor chat conversations were more effective. What was in the conversation, what did we find that was more sort of leading to uh, beneficial outcomes. Of course, it was a very small study, so we're not able to get to that question. But here's an example of a user, and AI is helping them design an experiment about drinking coffee and productivity. Right? Does drinking coffee improve productivity? And then the AI tutor will also talk about cake and tea, so just give you some ideas, and then helps you with a 2 by 2 factorial. And at the end, and then AI also helps you think about confounds. And that's very helpful when you are new to designing experiments, and you often think a lot about confounds. And so this was one of the feedbacks that we got from one of the users. It's a very good tool, and it gives suggestions that I wouldn't have considered at all. And so this was very helpful. And we learned this from qualitative feedback. Of course, we it was maybe not possible to learn this from the quantitative pre-post test data. And so this is why I believe both forms of data collection are important. So as an experimental designer, you just have this web application which you can use to create experiments and rapidly collect data, and then run your analysis. So now I'm going to share a little bit about. So now this is all learning engineering part that I wanted to share. And in the last part, I'll quickly share some things about smart paper. It's an effort to connect paper and digital learning. And let me share why. And in learning engineering, measurement is one of the key aspects in learning engineering, and using the measurement and specifically assessments, and using assessment data pre-post test to understand the growth in competencies, skills, what have you, whatever you can call it, knowledge components, knowledge acquisition of all types. And in education, specifically when you think about K-12, paper is a place where a lot of the data about student competency resides. There is a lot more to learn about students' knowledge on paper, probably compared to what's on the computer. And when you think about students today, whether it was COVID time or before or after COVID, paper is there everywhere, and there is just so much that we can learn about students from paper. And so that's one of the motivations to build smart paper. And I'll share some of the interesting kind of data that smart paper is able to collect now. um, and But smart paper is also a winner of the tools competition, uh, um, and that's few years ago. And smart paper has scaled to a big an entire state in India. I'll just share a bit about that. And the way it works is that there is a paper worksheets which has 4 QR codes, and it's a smart paper format. So you click a photo, and then it's evaluated, and you can collect the data. And of course, this is one version. There are several ways, others where you could capture handwriting, something from notebook. But the core idea is to collect learning data from paper, which then kind of somehow feeds into the learning engineering cycle. But when it comes to paper, one of the key things about paper is that it's an equitable medium. And I believe that when you have data of everyone, then you can do learning engineering at a different scale in a different system. So that's a key thing. And the way it works is that students will take assessments, and teachers will take pictures of their papers, and they are digitized. And this is from Rajasthan, where the government uses smart paper to evaluate answers, objective answer sheets of nearly 5 million students. And apart from objective, now smart paper can also read the handwriting to understand students. And one of the key things about smart paper is the scale that it operates on. And it's a massive scale. It created a world record of scanning the maximum number of answer sheets in one day. and it's in World Book of Records. And smart paper was able to do this because it was a reliable AI technology. And let me share you what it means to have reliable AI, maybe only in the context of smart paper, but it may apply in other places. Is when we tried building this technology, we saw that the way people can take pictures of papers can vary widely. So you can see these two pictures. On the left, you see someone has taken photo of worksheet from very far away, but just then you can see how smart paper is able to straighten the photo, clean it up, and grade the entire worksheet. So the AI technology, when we use it at a massive scale, has to have this reliability aspect, and it becomes very important. And this is really getting into building this measurement apparatus of student competencies in the service of larger vision of using data to improve learning outcomes, whether it is a digital system or whether it is a physical classroom system that you want to improve. But having an AI that is reliable is paramount, right? And when you are operating at that scale, let me show another example. This is an attendance sheet that you can digitize with smart paper. Now this attendance sheet has so many ticks in particular places. If you gave this to an LLM, it would completely falter. There is no way an LLM can read this, detailed sheet to extract answers. And this is where smart paper, having its features around reliability, is something that people can trust. And so when you're having AI in the learning engineering cycle, reliability becomes very important, specifically at scale, where if you have a scale of millions, then even a small percentage of error can become challenging. And so that is with digitizing simple marks like tick mark or cross mark. Smart people can also now grade handwritten answers, and the way to achieve reliability with handwritten answers is we use scoring rubrics. So for example, if you want to grade handwritten answer to, let's say, the science question, you don't just ask AI to score it, because if you do that, it will score differently every time it scores every student. That is not very reliable. So the way we do it is, in our system, is we provide these scoring rubrics, and that makes the grading reliable. And so similarly, it is important and to show, and also then when you are showing the grading to the student, and it also makes it transparent. So this reliability also then gives you another advantage, is that system also becomes transparent, and the student can see that in this rubric I got 2 out of 2, in this rubric I got 1 out of 2. So it becomes very easy for them also to understand things. And but this is particularly going and refining the measurement cycle of learning engineering. And then what becomes important when you're handwriting, or more interesting rather than important, is that you are able to then cluster these responses and find common mistakes, which can then again enhance your learning engineering cycle, because you know more about students. And then again, you have a better chance of making the system more effective by understanding what people are not understanding. And with handwriting data, I believe there is a unique opportunity. It's a data that doesn't exist. This type of sample of data of handwritten answers to questions. Here we did like a simple study with 100 students who all took same paper, and then we clustered their misconceptions. And it's a simple question: multiply 2y plus 5 times 2y plus 5. Not simple for kids. But when you look at the responses, you see these clusters of answers. the surprising part is that if you ask the same question to chat gpt or any latest llm and ask them ways in which students will get it wrong, the llms will not be able to predict the answers that students provide. The human misconceptions are quite distinct and what ai can come up with. And so here in this you can see 2i plus 5 times 2i plus 5, so they are multiplying, or rather they're adding things, and they're simplifying in a very unique way, which is hard for ai to guess. You could also, people also can add variables to and add their powers. So interesting. Now ai will is still not able to, in most of the cases, not guess these mistakes. And so what I believe is that having this data will be able to better tune, or better give better support and better sort of clarification of misconceptions within the, the digital learning ecosystem. And this is the most unique. Is the 2i plus 5 it becomes 7y, and then they are all, they're again added, so you can tell that they know multiplication, but they don't know certain other things. They know addition as well. And so these are very interesting ways to understand the learning abilities in more depth with handwriting data. So I believe that this data specifically from paper should be looked at and should be leveraged. And so just to recap now, I talked about learning engineering, which is using experimentation to find causal evidence for the efficacy of digital interventions, or either you have digital content. And so the core idea is that you're using randomized control trials that are online and where you can run rapid experiments, and this will enable you to continuously improve the digital learning efficacy. And for when you think about ai interventions at scale, then reliability of ai becomes a key part for making the efficacy work. And there is an interesting phrase called measure what you treasure, and it really fits well within the learning engineering cycle. But I also want to talk, just share this thing which is called Goodhart's law, that if a measure becomes a target, then it ceases to be a good measure. And so when you think about both things, numbers and anecdote, when you think about quantitative data and qualitative insights, to improve the edtech efficacy, both are equally important: quantitative experiments and qualitative insights. So I believe that we should be looking for both. Of course, in learning engineering, when you do experiments, quantitative measures are paramount. But when you think about holistic improvement, then we should be looking at both ends. So with that, I'm going to end my presentation. And if you want to connect with me, my website is nirmalpatel.net, and my email ID is also on my website. It's nirmal at playpowerlab.com. I'm happy to connect on social media and chat about learning engineering or anything edtech. I really love edtech, and I think it has a great potential to do good for society. So with that, I will end my presentation. Thank you, Briju, so much for this.
Wonderful. Thank you, Nirmal. It was very insightful session. So let me ask the participants who has any questions. So please post in the comments, YouTube comment session. So Nirmal will be able to answer those questions. And yeah, you can post in the comment. And so while we are waiting for the questions, and yeah, thank you very much, Nirmal. It was very insightful session to learn more about the work that you are doing with the CMU and the resources that you are shared, upgrade, and the resource. So yeah, some questions. So with let's say if someone wants to do uh, uh, and I know you touched about the ethical part, how we measure, and you suggested the online learning environment. It's not that much problem, but usually in the face-to-face sessions, when we collect more data, it might be some issue. Um, and also you shared the Google Classroom, Moodle, and other LMS. Also, you can use these resources to do tests. Uh, um, so if someone wants, especially with the, for example, here I am in a rural college here at the, and so the students, they have a lot of problem with the English language improvement, you know. So let's say if I am creating some prompt for uh, compare with one prompt with the another, which prompt would be much better prompt to improve their English speaking. So, what would be some of your recommendation? How do we measure that? How it's learning happening in for a
Okay.
layman, like a teacher? Let's say
Yeah.
if a teacher, school teacher, a local government school teacher wants to improve the students' English.
Okay. Yeah, yeah, that's a great question. I would start by developing the measure of the learning, like what so whether it's an assessment, it's a self-assessment, and then whether I think that is one key part, that what is my measurement. And then of course you can resource tool is ideal for running this type of experiment. So you would just go to resource.education. It's a free web app. So you sign up with Google, and you create an experiment. You enter the details of experiment, and then in the conditions, and then of course if you want pre-test, you can add pre-test questions. You can add and then you design the prompts, or you just enter the prompts. Then you set post test if you want, then you have a user feedback, and there is a closing. And when you create the experiment, you get a link. That link can be shared with anyone on WhatsApp, on Google Classroom, anywhere. You can post it anywhere, right? It's just a link. And then whenever anyone will open the link, they will get assigned one of the two, three prompts, whichever you have designed. And if you set it 10-minute session, they'll do 10 minutes. If it's 15 minutes, fine. If it's like, okay, if they can do as much as they want, that is also fine. They can then skip whenever or go to the next. And so according to however you said, the experiment will happen. And then on the back you will get all the data, which is first the basic information of the user, which will be anonymized, and pre-test, post-test, all of that. And in the chat, the entire chat conversation as well, which you can also then analyze to understand how people are talking. Because often people will not talk, they will just say small words, and they will not really talk with the AI. And then you see that, or if they're talking, then you can just get much more insight, right, by looking at their conversation with the chatbot. So you get entire that conversation as well. And then you get all of that and as a CSV file, and it's just one click export. You get the entire thing. You can also see some dashboard. On dashboard you can see enrollments. So let's say if 10 people open today, I'll see on the dashboard 10 enrollments today, 20 tomorrow. So I can see people doing it. So I get a rough idea that okay, people are engaging with the experiment. Then I can extract data, and then I can immediately start my analysis.
Wonderful. Great. So I think I saw some comments. Let's see. Okay. Okay. I think let me show there is one question from Felix. Um, what are the learning theories popularly used for your experiments?
So it's been some time since we haven't run many experiments in Smart Paper. In Battleship Number Line, we use theories primarily. I think around there is a lot of literature around games and education, and so those were the theories we did. One of the core things we used was this flow theory, also I think by Skizen Mihai. And that's the idea that you are in this optimal state where you get challenge which is not too much, not too little. And then you're in that optimal sort of flow state where you're enjoying your learning. It's not too difficult that you want to drop it, it's not too easy that you get bored. And that was a sort of primary theory that we try to kind of center things around. And then our hypothesis was that the longer you play this game, then more effective it is. But of course, there is, like, there is a lot of literature. I'm not aware of the more recent literature. I think we used to experiment long back with the games. So yeah.
Great, thank you. There is one more question from Srunika. How is language education different from, yeah, language education or social science? Yeah, sorry.
Okay. uh, I think, so not yet, but I think for language education it's particularly interesting looking at handwriting and how it develops. I would say that LLMs are not very good at reading children's handwriting right now compared to adults, um, and when you think about looking at how handwriting develops, I think it's so exciting to understand how handwriting develops over time, when you look at one child's handwriting being developed. And so I think that is, I believe that such data sets are not there. I don't know to what extent people have collected big data sets. Imagine if you're able to see handwriting development of 5,000 children, you may be able to discover various type of trajectories of development, that many children are showing similar trajectories. So I believe that those type of data will be very insightful and open sort of new avenues of answering some questions when we start looking at those data. And I think, yeah, and for other sort of, from assessment point of view in social science, yes, I think that is also, of course, that's an angle, that wherever you are doing assessments, handwritten assessments, then just ability to collect this handwriting data at scale immediately gives you a new kind of data. Where I showed some example of maths, but similarly, you could do, like, we did an exam in Java, for example, programming. So you would see similar things. We did one for science where, was so interesting to understand these misconceptions. The one I really liked was about students misunderstanding electric field lines, thinking that electrons move on those field lines. Now those are force field lines. The electrons don't move on those lines. And so when we looked at data, we understood these things, and then you can highlight this to teacher. And so that is another sort of efficacy lever, that you are able to use learning analytics, and learning analytics also becomes a way to improve the outcomes apart from other digital interventions.
Yes, okay, I don't see any other question, but I have one question regarding the language. I think similar to Sronika. Say, for example, you mentioned about the fraction, right? Like the fraction test. And let's say if the fifth grade student in Marathi or in Malayalam, Kerala, so sometimes they do write that explanation in Marathi or in Malayalam. Just let's say so from the smart paper, will it be able to identify the local language also?
Right now it's able to identify Hindi. I think in some time it will also identify. It is able to partially identify. We tested with Gujarati. I think it is was at about 60%, 60-70% correct, maybe a few months ago. Maybe so. And AI keeps improving every day, right? Hindi was also, I think Hindi is above 90% now, 92, 93% plus range, which was maybe around 80%, several months back. So I think it is improving, and with as more data is collected, things will improve. So because collecting data itself is a challenge, and when there is more data, I'm sure that's going to happen. I think it will have to happen in India because we are such a diverse country, so it must happen.
Comments. I think, yeah, Sronika also
Yeah.
made a comment on
Yeah,
that.
I think it does make sense, because if you are looking at essays, for example, of one student over time, you can see their vocabulary develop, right? You can understand, what they're writing, which words they're using. And then I think, and you can also, interestingly, then you can suggest them, as you have access to their written notes or whatever. Then I think it becomes very easy to then suggest them relevant things also.
Okay, so I think we are out of time now. And
Okay.
once again, I just want to thank you, Mr. Nirmal Patel, for joining this session and those who joined. So you can complete the quiz at the end to if you want to get a certificate. And also don't forget for our upcoming masterclass and also the T4E conference in IIT Madras. Looking forward to see you all. Thank you again for joining today's sessions.
Thank you.